Welcome back to another episode of Hands-on SAP Devs. Now, if you've watched my show over the last 10 plus weeks, you know that we've been really focused on a single project that we've been building up from scratch that showcases the capabilities of SAP HANA Cloud and the Cloud Application Programming Model, and doing all that development in the new Business Application Studio as well. Today, we're actually going to take a little bit of a break from that series. Don't worry, we'll go right back to it again next week and pick up where we left off. But for this week, there was certainly a special opportunity that I wanted to take advantage of and help promote something that SAP has just launched. And that's the fact that we now have a free trial as part of the SAP Cloud Platform for the Kyma runtime. And up to this point, you could primarily, as a developer, try out Kyma by installing the open source version, the Project Kyma, on a local development environment in Minikube, or maybe deploying it to one of the hyperscalers directly. But now we have a free version that is part of the SAP Cloud Platform, integrates with the identity management of the Cloud Platform. As we'll see, many of the service brokers are also available in the Kyma runtime side. But the thing in particular that I want to focus on today is how can we take a Cloud Application Programming Model application that uses SAP HANA Cloud as its persistence and deploy and run that from Kyma. So I think there's probably a lot of misconceptions out there that Cloud Application Programming Model applications are only designed for Cloud Foundry. But in fact, as we'll show you here today, it's actually very simple to take a Cloud Application Programming Model application and really with no code changes to the application itself, deploy it to Kyma as well. So just a quick few points about the Kyma trial itself before we get into the bulk of what we want to look at today, which is actually how we run the Cloud Application Programming Model applications on there. But what you'll see, if I go into my SAP Cloud Platform cockpit in my trial account, and if I go if I actually drill in here to my sub account, and then if I were to go to entitlements, configure entitlements and add service plans, what you should be able to see now is if you search for Kyma, is now the Kyma runtime is available to be added to your account. So if you had an existing trial account, you would have to go in here and add the entitlement. If you were to create a brand new trial account from scratch, then this entitlement should automatically be added, and you would see a screen like mine where it's grayed out. I can't add it because I already have it added to my account. Now, once you add that to your account, and we go back to the sub account, well, I went up one too many there, but what you'll see is Kyma environment, and instead of this button that says disable Kyma, you would have one that says enable Kyma. And you would press that button, and it would provision a Kyma instance for you. It takes a couple of minutes. I've already done that on my account, so I have a link to launch the dashboard. Now, the other thing that I'd point out, that after you enable Kyma, you do need to go in and assign the roles to a role collection. If you see here, I've created a Kyma role collection. And then if we were to look at inside that role collection, I've added the admin and developer roles to that role collection. And then I do need to, from the same security area, go into trust configuration, click on SAP default, look up my account, and if I do show assignments, you'll see that Kyma row collection is assigned. If you had just created it, you would have to say assign row collections and then choose it from the list. but all of mine are already signed. That's why there's none here in my dropdown. So if you do that before you first launch into the console, then the first time you launch in, everything will be fine. It will load. Otherwise, if you've already loaded it and you've got an error that you're not authorized, then you probably have to close out all your browsers because it'll be cached. But then when you relaunch it or try it in an incognito mode or something else like that, then when you click the link to dashboard, it should open just fine. It is using my identification from the SAP Cloud Platform, so the same identity management, but here I have launched into the Kyma console, which allows me to do diagnostics or see what applications, services, deployments have been done in my particular Kyma runtime. Now we'll come back to this later because we actually want to focus on doing development first, and then we'll deploy it here into Kyma and use this console to see the configuration that gets deployed for our application. So there's going to be a couple of tools that we're going to need in our development environment. First, we're going to need Kubectl, or some people call it Kubectl. This is the command line tool that you use to interact with any Kubernetes environment. Now, you should probably go look up the installation instructions for Kubectl in your particular OS. There's lots of package managers, different places you can go to download it from the internet. I'll put a couple links to some basic Kubernetes installation instructions. But I already have Kubectl installed on my in my development environment. So from any terminal window, I'll just use the one that's embedded here in VS Code for now. I'll just say Kubectl version. And what you'll see is I got my local client version. It says, error, you must be logged into the server. The server asks for the client to provide credentials. So I am not logged in or connected to my Kyma instance that's running on the cloud platform. But there's a very easy way to do that. If I switch back over here to the, if I find my right window, there we are. We go back to the Kyma console that we just launched here from the cloud platform cockpit, the link to dashboard, and we're over here in the dashboard. And we come up here to your user little icon, see who you're logged on as. But you can click this link that says get kubectl. And this is going to download the configuration file with your authentication information that you'll need from the Kubectl command line to connect to this particular Kubernetes cluster that Kyma is running on. And you want to download this to wherever your home.cube folder is that should have been created when you installed Kubectl. And by default, it will just be a file named config. So we're just going to overwrite this file named config with my current configuration. And that's downloaded. And now when I go back here to Kubectl and I say version, now it's connected to the server. I know that like I can issue other commands here like Kubectl get pods, and that will list some of the things that I already have deployed and running on my Kyma cluster. Now we'll come back to this later because this is sort of the end of the process after we've done development, but I just want to make sure that I've got all of my, I really have all of my tooling that I need set up here. The other part that I'm going to need is going to be Docker. So I installed Docker Desktop. So like if I do a Docker info would be a valid command. Let's see if that's, yeah, Docker info shows me that yes, I am installed and I have Docker Desktop installed, and some other technical information here about the versions and things like that. But basically, if I can do I'll do the Docker ps command, and it shows me Docker images that have been deployed on my system. Because this is going to be one of the major differences between doing cloud application programming model development and deploying it to Cloud Foundry. Because when we deploy it to Cloud Foundry, we create that MTA, that multi-target application, and then we deploy that, and it runs on top of the build packs of Cloud Foundry. And the build pack really provides the base image with OS libraries and things like that that will run within. In Kubernetes in general, and of course Kyma, as it runs on top of Kubernetes, really takes a different approach. There are no provided build packs or set environments. We have to build for each of our applications the complete environment image that we want. And we do that by building a Docker container and publishing that Docker container. And then that's what we actually deploy to Kubernetes. This means that we have more responsibility over the configuration of the underlying environment that our application will run in, but it also means we have much more control over that. You'll see that has its pros and cons, but it is part of the differences between Cloud Foundry and Kubernetes development, where in Cloud Foundry you have a opinionated model where some of the technical decisions have been made for you, but in the Kubernetes, and Kyma by extension, you have much more low-level control over the environmental setup. All right, let's start by creating a new CAP project. So let's use the Yeoman UI generators, and then we'll choose the CAP project. And what do we want to add to our project? Enter the project name. Let's just call this Kyma 2, because I know I've created a couple other projects with Kyma as the name. We know we want HANA. We actually don't need an MTA since we're going to target Kyma and Kubernetes, although we could always come back and add it later if we also wanted to be able to support deployment to Cloud Foundry. I'll go ahead and put a pipeline. We'll use the samples. So we'll just deploy the basic sample application that gets generated. Go ahead and say next and let this generate our project. And we'll go ahead and then open the project that has just been created. Here we are. We have our Kyma 2 project. And if we were to look at the structure, not a whole lot in here yet. We have our basic data model with just our books table. And we have our catalog service that exposes books. And we got a little CSV file that puts 2 entries in the books. That's enough to serve our purpose. We're more interested in how we prepare our project for deployment to Kyma. Doesn't really matter what's going on too much inside of our project, so we'll just go with the sample here. That works for me. Let's do a quick adjustment to our package.json. Let's change this to version 2.5. And then I like a couple other scripts here. Let's see. Start CDS run. And I'm going to add a HANA script to help me out here. CDS deploy to HANA. And we'll call this Kyma 2 for our container name with a auto undeploy. Let's go ahead and create a script here for building. And that's just going to be CDS build all clean. Okay. And we're going to say requires HANA. We want to go directly to HANA. And I need to add my HANA and deploy format, since we're going to target HANA Cloud. Deploy format HDB table. There we go. That looks good to me. So now from the root of our directory, let's see, yeah, I am in that directory. Let's run an npm install. That'll pick up our dependencies. There we are. So we've got our node dependencies, and now we can run a npm run build. That will run our build script, which will just do a cds build all clean. And we should see that built out, and it created our HDB tables, HDB table data. That all looks good. And if we want to go ahead and send this to HANA, the only thing I need to do here is do a CF login real quick, and that's what I was afraid of. I'm at the wrong endpoint because I was doing some other work the other day. So CF login-a and change this to the US region. To my trial account, and there we are. Services, just make sure I'm in the right spot. I don't want to send this accidentally to the wrong place. Yes, that looks good. So now I can just issue, I'll just issue the npm run HANA, which will send a CDS deploy to HANA. And what this is going to do is fail on me. All right, so apologize for the error that I got. I thought I had already installed the crypto library on my local development environment, but maybe I hadn't. Maybe I had done it somewhere else. That was the error message I was getting, that there was a dependent crypto library that needed to be installed. So I downloaded it from the Service Marketplace. Now I have it. I'm good. And now I can continue with my npm run HANA. I'm just going to call my CDS deploy to HANA. And what we'll see here is it is connecting to Cloud Foundry and creating the instance of my HDI container, which I named Kyma 2. I put it here in the script command. So it will take just a minute to create that HDI container. It'll create the key. It'll write my default-env.json for me, and then it will do my initial deploy into that container. So we'll give it a minute to do its work. It's created the HDI container. Now it's creating the service key. And now that that's done, it's going to do the initial deployment into the HANA database. And there we see it's deployed our content. And actually, because it was so gracious as to even write a default env JSON into our root folder, we can now do things like HANA CLI tables. And we see it's created our bookshop books. CLI table, my bookshop books. And there's the structure of our table. So it's created it in the HANA database. We're good to go there. And we can even say npm start, which is just going to run a CDS run for us. It's connecting to the HANA Cloud system. It launched on localhost 4004. And if I open that in another window, there's the CDS test page. I can go to my books, and I can see my 2 records. So I have a running CAP service. Other than the little thing about my missing crypto library, that was pretty fast. Start to finish, generate project to deployed project on the HANA Cloud service to already running, at least locally, the service here. So the next thing we need to do is Dockerize our service so we can get it ready to deploy to Kubernetes. So now we want to create a Docker container for our application. And I added a couple of files while the video was paused to just help us, well, mainly, so you don't have to watch me type too much. But the main file that we're going to need is a Docker file. And this is where we're going to do all the configuration of our environment and tell it what we want. Actually, I made a mistake there. Tell it what we want to do when it starts up. So for instance, we're going to tell it what base Docker image to work from. And I just want a Node.js environment, and I can specify the particular version. I said 12.18.1 because that's what I installed locally on my development machine. That way I get a good, when I test locally, I know I'm going to get the same thing when I run in my Docker container. I'm going to create a working directory, and then I'm going to copy my package.json into that working directory, run an npm install, and then I'm going to copy my source files into that directory as well. And then I'll expose port 4004 because that's what the CAP application will run on by default. And then I'm going to issue the command cds run that will kick things off. So I've already tested it locally on my machine, but now I want to build the Docker image and then test the Docker image locally as well before I deploy it to Kubernetes. Now I could issue these commands directly, but I have a tendency to forget what they are and have to go look them up, like -t, -f, what does that mean? I tend to create little script files that help me with this. Doesn't matter, we can either run the script or I can just run this command. But basically what we want to say is Docker, please build to an image named, and this is my namespace, and this is the specific image that I decided to name my Docker container. Just happen to name it the same as my project. It doesn't have to be. You can give it a version number. I'm just saying latest. And then use the specification from this Docker file. Okay? Pretty straightforward. We'll go here to the command line and we will run that. And assuming I didn't mess it up, it's now pulling the base image from the central Docker repository on the internet. So that's what you see it downloading these main pieces for to get the Node.js version 12.18 and the other operating system components of the skinny base Linux version that it's going to lay down. So we'll give that just a minute to completely download. There we are. Now it's moved on. It's created our working directory. It's copied our files. Now it's running npm install inside the Docker container, not in my file system of my local development system's operating system, but inside the Docker container itself. It is still running npm, but you see some of the progress. There we are, and it is finished building that Docker container. Now we can test this Docker container by running it locally. We also see here that now my Docker images display in Visual Studio Code shows me that yes, there is this Docker image, but it's not running yet. There I see my running images. So let's go ahead and do a Docker run. All we have to do here is say what image we want to run, and we can do a port mapping. It's running on port 4004 internally, but we can actually map that to any other external port number. So if that would give us a conflict with something else running in our local environment, we could map it to a completely different external port. I shouldn't have any problem. It ran on 4004 fine when it did locally, so we'll go ahead and run that 4004 in the Docker container. So we'll go ahead and say Docker run. And now that is running. And it looks like I probably messed up because it exited. So let's go ahead and look at the logs. And can't find module. source app CDS. And yes, I evidently did make a little mistake. I didn't have to end up changing my paths. I just changed the command to npm start, which if you remember from our package.json, the start script ran CDS run. It's probably better to go off of a start script anyway, but that appears to work rather than calling CDS directly. So I'll show you the process here. Now that it works, we'll just go ahead and build again. And when you build subsequent times, it doesn't have to re-download the base image, so it didn't take any time at all. And even if I would make some change to my development objects, I can rebuild, and it's very fast. It just does a delta. Same thing when we'll publish later to the central Docker repository. That also happens very fast because it only sends the deltas after the initial. So now I can do a Docker run. And this is where I really like the Docker container tools that you can add into Visual Studio Code, because I can see here, now I see my Docker container is running. For instance, I can go in and view the logs. And like before where I got an error, here I can see the logs. It connected to HANA. Now, it only connected to HANA because we sent the default-env.json into the Docker container. We don't want to do that when we send it over to Kubernetes, because we actually want to map that not to some local file in the Docker container, but we want to get that out of there. That's only good for testing, and we'll see how we configure that in Kyma itself. But in the meantime, it has connected, and if we run the localhost 4004, now it's running. And this isn't running in my shell inside of inside VS Code or my local service or my local desktop. This is now running inside my Docker container, which is I'm actually running Docker for Linux in Windows Subsystem for Linux 2. So it's being routed through over to that Docker that virtualized Docker container. So I know this should work now. If I deploy this to Kubernetes, I've got a good working container. I'll just close that. You can see here you can also you can shell into the container as well. And for instance, I can see what has been set up. See, I can see the default env is there. I want to get rid of that though, because I don't want that going over to Kubernetes. So now I can go to my Docker ignore. These are files that are in my project. Which part of my project do I want to not go into the container when I create the Docker container? So I can just say default env star JSON. And that'll make sure that no files with that structure go into Docker. So let's exit out of there. Now, let's build this again. And let's also stop the one that's out there. Let's remove it. There we are, it's rebuilt. And let's run it again. And this time, 1 second, but if we look at the logs, you'll see that it's not connected to the HANA database, because it didn't have the default env.json, and now when we run it, yes, it crashes. That is actually what we want to happen, and we can verify that, well, if we were to restart it, verify that by shelling into our Docker container, doing a ls, and notice no default env.json anymore in the Docker Docker image. So that's what we want our Docker image to have. There, exit out. We can stop that, and I actually don't need that in my local Docker anymore, for now at least. I can remove that. So now what we want to do is we want to do a Docker push. One, Kyma 2, oops, 2, latest. And now this is pushing it up to the central docker.io registry. So anybody else with a connection to Docker could pull and use this container. I'm publishing it publicly, and that's what's going to make it accessible to my to Kyma running on the cloud platform. It's going to be able to pull this Docker image and deploy it onto Kubernetes as well. There we are. It's done. It actually only pushes my unique components. You see others are mounted from the other, the base node library, so we don't get a lot of repeating of content. There's no copying of the base node image. It will just refer that and then pull that in when it needs it. It's not actually storing that in my content. And we can verify this here if we would go to Docker Hub here. Log in. And here we see, just uploaded a minute ago, was my Kyma 2. And we can even see a little bit of information about this, that it's a Linux image. Shows us a little bit of information, but we know it's here. We know it's good and ready to be used in Kubernetes now. Our final step is going to be to push this to Kubernetes, the Kyma runtime. And to do that, we really just need a deployment YAML. This is very similar to the MTA YAML, both in structure and in purpose. Basically, what we're saying is what we want to be deployed and how we want to configure it. So logically very similar. And what we're saying here is we want to create a deployment of our application, and we can do some configuration here of, what do we want to name it. But the important thing here, I missed this, is we have to tell it our Docker image that we want it to pull. So I'm saying pull Thomas Young 1, Kyma 2, latest version. And we have our port specification that it is expected to run on port 4004. And once again here, I'm going to layer a service on top of it to expose it outside of Kyma. And I can do a port mapping here as well. So I'm saying its internal port is 4004, and we're going to map it to an external port of 4004 as well. That's going to expose it out to the internet. The really important part here, though, is the fact that we are creating a secret, and the secret, which we also named Kyma 2, I put that in a separate file. If we look at the secret, what this is we're basically loading information that we want to be stored secretly in Kubernetes, and this is our connection information to the HANA database, including the username and password and connection string. Now, the nice thing about this is the default-env.json that was generated by the CAP deploy 2 has all that connection information that it looked up from Cloud Foundry when it created the service instance. And all I had to do was cut and paste the credentials section and put it in the string data section of the secret. And that will get written into a Kubernetes secret. Now, that is a little bit of a workaround because actually, if we go here to the Kyma console and we look at the catalog, there are many services that are already supported. These are Cloud Foundry services that are supported directly in the Kyma runtime as well. And I have the ability, very similar to Cloud Foundry, to come here and simply create an instance of one of these, like I did with the XSUAA. When I create an instance of one of these provided services, all it does is create, well, one of the main things it does is create a secret for it and store those credentials here inside that secret. This is very similar to the VCAP environment that gets created in Cloud Foundry when I create an instance of the service. But if you notice here in the catalog, HANA Cloud is not one of the options yet. We do not yet have all of the services from the from the Cloud Foundry side, also exposed in the service catalog of the Kyma side. But that's okay. That doesn't stop us from being able to deploy or use this functionality. It just means we have to create the secret manually. And as I said, we can do this very simply, either by going to the Cloud Platform cockpit and looking up the service instance details, or, as I said, the CDS deploy already did that for us and wrote it into the default-env.json for our local testing, and all we had to do is cut and paste it into the secret file. Now, the other really key thing is we have to map this secret, or we have to mount this secret, and we need to do it in a very specific way. The xsenv modules that are used by the app router, by Cloud Application Programming Model, the HDI deployer, they're all written to already understand Kyma and Kubernetes, but they're going to look for that secret in a very special mounting path. Because what we have to do is create a path called /etc secrets. Then you must name the next folder in the path SAP CP for Cloud Platform. Then you use the name of the service instance type, HANA, in this case, because we want to map our HANA credentials. And then the service instance name, which is Kyma 2 in this case, which is simply what we called it. If you remember back, if we go all the way back to our package.json, I said CDS deploy to HANA Kyma 2. This is the service instance. And if I do CF services, you'll see that Kyma 2 is the name of the service instance. So that's all we're doing here in the deployment, is we're telling it to map to service type HANA, there's the HANA, and service instance name Kyma 2, there's the Kyma 2, but to read the secret to supply all those details. And here's the secret details that we have. That's all we need to do now, and we're ready to actually issue a deployment. And once again, we'll just use the kubectl, and we'll say force replace whatever you find in the definition, and we'll create the secret first, and then we'll deploy the rest. I always put my secrets in a separate configuration file. That way, if I need to, I can leave them out. For instance, if I was pushing this to GitHub, I would put a git ignore for the secret JSON, so it did not actually go to the central source code repository, because I don't want any credentials getting copied around like that. It's only good for local testing and the final deployment. But if I go ahead and either issue these commands separately, let's do that. We'll say kubectl replace secret JSON, and what that should do, it connected to Kyma, and it created a secret named Kyma 2. And we can already go over here, if I go back and I look at my secrets, and already we have Kyma 2, and for instance, the certificate, the HDI password, the HDI user, although it's base 64 encoded here, we're not seeing the values directly. It is obfuscated by base 64 encoding, but it's good, it's ready to go. And now if I do the second command to send our main deployment into Kyma, here we are. It has deployed the application and the service. So now, once again, if I go back to the console, what we should see here, we should see a pod for our Kyma 2. It is waiting, so it's pulling the Docker image right now, and then it will start it up. So we'll give this just a minute. It doesn't take terribly long, but just like when you deploy your MTA to Cloud Foundry, it takes a little bit of time to initialize and then get running. Actually, while I was talking there, it already went to the running status, so that's good. It is running. So we have a pod, that's the base image. Then we have a deployment, Kyma 2, running with this Kyma 2 image. It is running as well. And if we come here, it created a Kyma 2 service, which is mapped to port 4004, and it is running as well. And then if we want to expose that to the internet, we just need to give it a host name. So host name for host name routing, Kyma 2, and we can configure our security on it. JUT tokens, OAuth. We'll just make it anonymous for now to keep things simple for testing. There we are. We'll say create. And now we can go ahead and open that in a new browser window. There is our CAP service. There's our books. And, ooh, I got a connection failure. That's interesting. I assume that is getting an error connecting to the HANA database. That's not exactly what I wanted to happen, was it? All right, I have to admit, I got totally fooled here. And it's a great learning opportunity. This whole mapping of secrets, Etsy secrets, the SAP HANA Kyma with the type and everything that I explained, I tested this all out in advance, but I actually didn't test it with the Cloud Application Programming Model. I tested it with my own logic using the xsenv module. So if you come here to npm.js and you look up SAP xsenv and go in here and look at Kubernetes, it's got a host section on Kubernetes that explains this. It all worked great with xsenv. It worked great with my own HDB-ext modules. It worked great with the application router, which was using xsenv internally. And I assumed that CAP was using xsenv. I was wrong. It does not use xsenv. I went and looked in the code. It loads from VCAP services itself directly. Now, that means that really to catch up to like some of the other modules, CAP should probably either adjust its logic or use xsenv. I'm not sure the reasons why. But once again, great learning opportunity, because this forced me to figure out how to do the same sort of thing without the xsenv construct that's described here with the certain path of the secrets. And it wasn't really all that different, nor all that more difficult. I'm still mapping the secrets, because maybe I want to add some logic that uses the xsenv. That's fine. But what I also created is environment from a config map. Another concept with a config map of creating something very similar to a secret, but allows us to load directly into an environment instead of just loading a flat structure as a secret would do. And what I've done, just temporarily to test this out, I would pull this out into a separate config file just like I had done the secret. But here temporarily, so I can finish the video and do the full explanation to you, I just added the config map to my main deployment. And unlike the secret, which takes just the credentials section and flat structure of the credentials section, the rest of the mapping and structuring is done by the xsenv file, because CAP is looking directly for VCAP services, I directly inject an environment variable called VCAP services, and then you use this little, use the special, I forget what you even call this, the straight up dash on the keyboard, the pipe symbol. That's it, the pipe symbol, to let YAML know that you're going to give it something structured here. So then I give it the straight JSON of the entire VCAP services. And now this is going to inject into the environment in Kubernetes, just like VCAP services gets injected in Cloud Foundry. And now CAP isn't going to know any different. So maybe not as nice or elegant as the special secrets approach that is supported by xsenv, but also certainly not impossible to pull off and execute. Just threw me for a loop there, like I said, because I had made an assumption that turned out not to be true. And now that I've deployed this again, you can see here I ran the deployment and it sent my new configuration through. And yes, if I come over here to my pod, it has restarted. And if I were to, and I lost my spot here where I had my test. There's my Kyma 2. And now let's open it in another tab. There's our book service. And now when I run the book service, now I get my data back. It was simply the mapping of the credentials, as we saw here, that I expected it to use the xsenv internally and follow the rules that are set out by it. It doesn't. It looks for VCAP specifically. It inspects the environment directly. So we adjusted our logic. But in the meantime, we've learned two different ways that from Kyma we can set up configuration here. Either anything that goes through xsenv we can do through the secrets approach. Anything else that's looking specifically for VCAP services, we can emulate using the config map. So threw me for a loop a little bit, like I said, but actually not a bad thing to experience because we got to learn from that experience as well.